So, Lana, welcome to our today's lesson, maths lesson. And as I promised you yesterday, today we will be dealing with area of a cylinder. But before we do that, let us remind ourselves of what we did in our last lesson. Now, in our last lesson, we were discussing a surface area of a cuboid, and we said a cuboid is something that looks like this, which has 6 faces when closed. A closed one, closed cuboid has 6 faces. So you are trying to get the surface area. Surface area is just simply the area, because cuboid is made up of rectangular faces. So we're just getting the length times width times the number of surfaces that faces that we have. This 6 centimeter, 8 centimeter by 5 centimeter, it means our surface area will be the surface area of this rectangular shape, which is 6, length is 6, and a height of width of 5. And then there are 2. You multiply that by 2. That is going to give you 6 times 5, which is 30, times 2 is going to be 60 centimeters squared. Then on this face, it is measuring 8 centimeters by 5 centimeters, but there are 2. So 8 times 5, then you multiply that by 2. That will give you 80 centimeters squared. Then the below one, which is the top one, you can see the top one has a width of 6 centimeters and a length of 8 centimeters. So this is going to be 8 times 6. Then there are 2, because it's a closed one. That will give you 96 centimeters squared. If you add this, you're going to get 6. You're going to get 17 plus 6 is going to be 23. So 206 centimeters squared will be the total area of that particular cuboid. Assuming this particular cuboid was open on one side, meaning that the number of faces reduced to become 5. So let's put the same measurements we have here, and 5 centimeter. Meaning that if it's open, we are going to put that arrow to ensure that we can be able to see inside, such that it looks like that. And so we have 6 times 5 length and width, which is our height. So 6 times 5 times 2, that is going to give you 6 centimeters squared. Then we have 8, this face, 8 times 5, 8 times 5, and there are 2. That is going to give you 80 centimeters squared. And then we have the lower one, which is measuring 6 by 8, but it's only 1 because the upper one is not there. So this is going to be 6 times 8, that is multiplied by 1 to give you 48 centimeters squared. The total area will be equal to 8, 12, 8. So 108 centimeters squared. If you compare this surface area and this one is more compared to that, meaning that one part is not there, so that's what is bringing the difference in area. So that's how you do it. It's not something difficult. That's how you calculate it. So we move to our lesson of today, and in our lesson of today, we are going to discuss about the area of a cylinder. Just to remind you what a cylinder looks like, I have an example of a cylinder here. A cylinder looks like this. It's a round surface which is curved, and then 2 parts which are circular. You can see this is circular. The below one is also circular. So there is this curved surface, the curved surface, and 2 circular parts. One circular part and another circular part. If we can cut this, we can cut it like this and remove. It is going to be a circle, make a circle. If we cut this, it's going to make a circle. And then we can also make a cut here and then stretch it. When you stretch it, it is going to make a rectangle. So this is exactly what it looks, the cylinder looks like. So we are going to draw an example of one here. So our cylinder is going to look like this. Our cylinder is going to appear like that, whereby there are 2 circular parts, this part and this, then the curved surface, the center part which is curved. So for us to be able to understand how to get the total surface area of this particular cylinder, we are going to separate this cylinder the way I've said. So we remove this part which is circular, we remove this part which is circular, we remain with the curved surface, and the curved surface we cut it at the center there, and then we stretch it to see what we are going to form. So if you do that, after you cut well, you are going to cut and stretch it. It will form a rectangle like that. Then the two circular parts are going to come on that side. Circular part, another circular part. So we want to get the area of these three faces, three shapes. Now I want you to understand this. If you look at this distance, the distance, if you get a string and tie it around this cylinder, we tie it around this cylinder. I think you can have this one to be the string. So we are going to tie it here. If we tie around this place, just like that, well, like this, to make something like this. I want you to see, Lana. I want us to tie it so well here, up to that. So you can be able to see we have tied it so well here around this surface, like this, like that. Then we remove it now. Whatever we tied there around this place is going to be the length of that rectangle, because this rectangle is just wound around that particular circle. So this surface, which we have, the string that the length of the string that we have put around this curved surface is going to be the length of the rectangle. So this we are going to stretch it and place it like this. So these are going to be our length. Then this part here is going to be our height. So this is going to be length, and this is going to be our height. I want you to see that, Lana, well. That whatever we put round that string is equivalent to the length of the rectangle. The length of the rectangle. Because it's the same as also the length of the circle, which is called circumference in this manner. So the circumference of the circle is equivalent to the length of the rectangle. And so we want to give our cylinder measurements: 7 centimeters radius and a height of 10 centimeters. And then you are told calculate this the area. Now we are going to calculate the area without using the formula. So this one we are not going to use the formula. So we have said the height becomes our width. So in this case, we don't have height in a rectangle. We don't have a width in a rectangle. What we have is we have a width, we don't have a height. So this 10 centimeter is going to come on this side. So our width is 10 centimeter. So we need to get the length. We need to get the length of the rectangle. Now I told you the length of the rectangle is the circumference of the circle. That is what is going to give us the length. How big is circumference? Circumference is equals to pi d. So this is going to be pi d. If you want to get the length, we get pi d. So for us to be able to calculate to get pi d, that is 22 over 7. The diameter, because this is radius 7, so the diameter is going to be times 2 to get 14. Times 14. That is going to be 44. So our length is going to be 44 centimeters, which is equivalent to the pi d. I've just said that. So we have gotten now the measurements of the rectangle. What we are not having is the now area, because we are looking for area. Remember, we are looking for these measurements so that we can be able to calculate the area. So the rectangular shape area is going to be length times width. Lana. So our area is going to be, the length we have gotten is 44 centimeters and the width is 10 centimeters. And that is going to give us 440 centimeters squared. So one shape, we are done with one shape, the rectangular shape. Now what is remaining is the two circular parts. But remember, previously we did about area of a circle. So we can easily get the area of a circle, where our circles have a radius of 7. And so, how do we get area of a circle? Area of a circle is equals to pi r squared. But remember, learner, these are two circles and all of them are equal. So we are going to say 2 pi r squared to be able to get this and this one. Let's see, area is supposed to go 2 times pi, 22 over 7, times radius, radius is 7, so 7 times 7, radius squared, radius squared. So by 7, 1, by 7, 1, this is going to be 44. Then 44 times 7, which is 308 centimeters square. So the total surface area, which sometimes will be written TSA, is equals to the area of the circular pass, which is 308 centimeters squared, plus the area of the rectangular parts, which is 440 centimeters squared. And the total area for these two is going to be 748. So the total area is going to be 748 centimeters squared. 748 centimeters squared. Learner can be able to follow well and see where we started and where we are ending. So the area is going to be 748 centimeters squared. Let's do another question. Remember, in this case, we are not using any formula. We are just getting the answers from what we know, from what we did last. So we are going to get another cylinder, and our cylinder in this case is going to measure 20 centimeters by, our diameter is going to be 21 centimeter. Our diameter is going to be 21 centimeter. It's not a must that you are given the radius. They will give you diameter because they know how you can be able to get a radius. You get the diameter divided by 2, you get the radius. And so, we want the total surface area, so we draw something like this. This gives us the rectangular part after removing these two circles. So one circle will be here, and the other circle will be here. So we are going to have those two circles. So the diameter of 21 centimeters each. And then, our height here, I say it again, our height becomes the width of the rectangle. So how do we get the length? Because length is not given in this case. Length is going to be equal, I say length is equals to the circumference of the circle. And how do we get circumference? Circumference is equals to pi d. That is going to be 22 over 7 times diameter. The diameter is 21. This is going to be 3. And so this is going to be 66 centimeters. Remember, this 66 centimeters is the length of that rectangle. Now we are done with that. So the area of the rectangle is going to be length times width, and that is going to be 66 times 20 centimeters. That is going to be 1,320 centimeters squared. That is the area of the rectangle. Remember, we have those two circles. We have not yet gotten the area. So we are going to have to get the area of the two circles. Now, how do we get the area of the two circles? We know area of a circle is gotten by pi r squared. But these are 2. So 2 pi r squared. So area is going to be 2 times pi, 22 over 7, times radius. If you look at this one, this is diameter. So for us to be able to get radius, we divide this by 2. So the radius is going to be 21 over 2 times 21 over 2. This is radius times radius. I'm avoiding to divide so that I get here 10.5. So I'm using the 2 here so that I can be able to divide with it. So by 2 1, by 2 11, by 2 1, by 2 1, by 7 1, by 7 3. This is going to be 33 times 21. 33 times 21. 3 3 6 6. 3 9 6. So the total area of the two circles is going to be 603 centimeters squared. So the total surface area of the cylinder is going to be the area of the circular pass, 603 centimeters squared, plus the area of the rectangle, 1,320 centimeters squared. This is going to give you 693, 3102, 2013 centimeters squared. 2013 centimeters squared. So that will be the surface area of that particular cylinder. So now you can be able to see how we are getting the measurements, because sometimes we'll be asked the question, like what we are going to see in the first exercise. They are going to ask you to calculate the surface area without using the formula. So this is exactly what you do. Now this is a closed cylinder. We go to an open cylinder, because if you can have a cylinder that is open, like for example, if we have a cup is a good example of an open cylinder. Look at the base of the cup. It's only one circular part, but on top there is nothing. So this is an example of an open cylinder. So let's see how we get the area of that. So if our cylinder is open, we are going to work out with an open cylinder. So our cylinder is going to be like that, 10 centimeter, diameter of 28 centimeter. But it's an open cylinder. Open cylinder. So in our open cylinder, we are going to do the same. We are going to remove the circular parts at the below, and then we cut this so that we can stretch to make a rectangle. And so we are going to remain with something like this. The height here becomes the width. And then we are going to have one circular part, the below one. So the top one is not there. So we are going to remain with the below one with a diameter of 28 centimeters. And so what we did, the same process we followed is what we are going to get here. So number one is to look for this length of the rectangle. So the length of the rectangle is calculated by getting the circumference of the circle. The circumference of the circle. And circumference is equals to pi d. Pi 22/7. The diameter is 28. That is going to give you 88. So this is going to be 88 centimeters. So can you be able to get the area of the rectangle? Yes, area of the rectangle is equals to length times width. We have the length and we have the width. So this is going to be area 88 centimeters times 10 centimeters. And this is going to give you 880 centimeters squared. 880 centimeters squared. From there now, we go to the circle. We can get we want the area of the circle now. How do we get the area of a circle? The area of a circle is given by pi r squared. Remember, there are not two circles, it's only one. And so the one, we cannot write the one here, though it's there. The coefficient of this pi is 1, though we don't write it here. So 1 pi r squared, which is just pi r squared, because we have one circular part. So this is going to be, area is going to be 22/7. The radius, remember the diameter is 20, so the radius is going to be 14 times 14. This is going to give you 44 times 14. 44 times 14 is 616 centimeters squared. So the total surface area is going to be the area of the circular part, 616 centimeters squared, add to the area of the curved surface, 880 centimeters squared. This is going to give you 6914, 1496 centimeters squared. 1496 centimeters squared. That will be the area of that particular open cylinder. So I think now you are seeing what we are doing, that we must get first the length of the rectangular part, and then the width of the rectangular part. That is what we are supposed to do. So we are going to move to do another simple one question before I give you the formula now. Formula of getting the total surface area of a cylinder. I want to pick a question from the book, and the question is, find the surface area of the following cylinders. Now from there, I want to do a question here, which is given like this. Find the area of the curved surface for each of the following. Find the area of the curved surface. Find the area of the curved surface. Now, first question is going to be like this, and you are given the circumference. So they are drawing something like this. To mean circumference is equals to 20 centimeters. The circumference is 20 centimeters, and this is 8 centimeters. Good. So we are going to move and be able to calculate the surface area of the curved surface. Remember, the curved surface is just the surface area of the rectangular part. That is what we are interested in. The curved surface is the area of the rectangular part only. This is what we call the curved surface. The rectangular part, not the circulars, no. This part only is what we call the curved surface. So our curved surface has a width of 8 centimeters. And we are told because this one has a circumference of 20 centimeters. What did we say, Lana? That the length of this particular rectangle is the circumference of the circle. The circumference of the circle. So the circumference of the circle is 20 centimeters. So we don't need to calculate the length because we are given the circumference. And circumference is the length. Remember what we say? And so our question is direct. The area is going to be the length times width. The area will be equal to 8 times 20. That is going to give you 160 centimeters squared. Full stop. That will be our area of the curved surface. If they wanted the area of the curved surface, the total surface area, then you would add these two circulars, but they did not want that. I want to do the last question about that. When you are not given the circumference and you ask about the curved surface, I'm going to give you this cylinder, which is measuring the radius is going to be 28 centimeters and the height is 7 centimeters. And they ask you to calculate the curved surface area. Curved surface area is written as CSA, curved surface area. And this is going to be, if you want to get this question correctly, Lana, without using the formula, you draw like that. Then this 7 is the width. And then here, how do we get length? Our length is equal to the circumference of the circle. I'm repeating that, Lana, for a million times now. So our length is going to be the circumference now. Circumference is equal to pi d. Pi, 22 over 7. The diameter now is going to be 28 times 2 because this is radius. That is going to be 56 centimeters. So this is going to be 8 times 22 is 176. So this is going to be 176 centimeters. So our curved surface area is going to be 176, which is length times width of 7. So if you calculate that well, you're going to get 2 carry 4. 49 plus 4 is 53, carry 5, this is 2. So you are going to get area 1,232 centimeters squared. 1,232 centimeters squared. So that's where we are, learners. So from there, now I want to give you the formula because we were doing without a formula. We separated the formulas. But now we want to combine these formulas. Whenever you are given an open cylinder, what is the formula? Whenever you are given a closed cylinder, what is the formula? So the formula is here, Lana. Closed cylinder area formula, closed cylinder formula. I want to draw the cylinder here. The closed one looks like this, 7 centimeters. This is 10 centimeters. Meaning if it's open, it's closed, then has 2 circular parts. This is going to be 10 centimeters. And then the radius is going to be 7 centimeters. Now, I want to bring you to where we started from. How did we get, Lana? How did we get this length? That length was gotten by pi d, the circumference of a circle. And then, what is this? The width is equal to height. Remember what I told you. The width is equivalent to height. So we are done with that. So the curved surface area formula is equals to pi d h. Pi multiplied by diameter times height. Pi dh. In this case, we are not going to talk about the width here. We are not going to talk about the width. Now, we are done with that. Then we come to the circular parts. The circular parts area the circular path area is going to be, remember there are 2, and area of a circle is pi r squared. So it's going to be 2 pi r squared. 2 pi r squared. That is for a closed cylinder. So the total surface area of a cylinder, a closed one, the formula is the area of the two circular paths, 2 pi r squared plus the area of the curved surface, pi d h. Learn that is how we get area of a closed cylinder. 2 pi r squared plus pi dh. So in our case, we are going to use this formula to calculate this. We are going to use this formula to calculate this. So let's calculate very fast. We will not use the formula. We are going to use okay, let's use the formula so that will move very fast. So our cylinder looks like this with 7 radius, 7 centimeters, and height of 7 centimeters. So we get the area is equals to 2 pi r squared plus pi d h. The first thing learn is to write the formula. This formula is a sharing of what you are doing. If you don't have this formula, you cannot calculate any question. Area will be equal to 2, just copy it the way it is, times pi 22/7 radius squared. Put in bracket plus pi 22/7 diameter. Diameter is this times 2, 14, and the height 7. Add those. By 7 1 by 7 1, this is going to be 44. 44 times 7 is 308 plus by 7 1 by 7 2. 44 times 7 again is 308 plus 308. So this is going to give you 616 centimeters squared. The total surface area is going to be that. So when you're using the formula, that is exactly what you do. Now let's move very quickly to an open cylinder. Open cylinder formula. Open cylinder formula. An open cylinder is going to be like this. I'm going to use the same cylinder I'm using. So this let's make this 14 centimeters and this 7 centimeters. If it's open, we are going to have one circular part and the curved surface. How do we get the area of the curved surface? Length, which is pi d, times height, which is width. And how do we get area of this? The area of a circle is pi r squared. So the total surface area of an open cylinder is going to be this one here. We start with the circular path learner. So pi r squared, because they are not 2, it's only 1. So we can put 1 pi, but it's not important. So pi r squared plus pi dh. So an open cylinder is going to carry that formula. Remember now we have removed 1 circular, so we are not putting 2 here. So it is a formula minus 1 circle. Just the formula of all cylinder minus 1 circle. Pi r squared plus pi dh. Let's calculate this very fast. Now using the formula. So area is equals to pi r squared plus pi dh. Area is going to be pi 22/7. The radius is 14. 14 times 14. That is radius squared plus pi 22/7 times diameter. Diameter is going to be this times 2, which is 28. And then height is going to be 7. This is going to give you 44 times this 616 centimeters squared plus by 7 174. This is going to be 88 times 7. 6 carry 5, 56, 61. Again 616 centimeters squared. If you add this, it's going to be 1232. Area is equals to 1232 centimeters squared. The total surface area is going to be 1232 centimeters squared. So very, very important, learner, you must be able to get the formula right. If you begin with the formula right, you are going to get the question also right. So for our practice questions, want to stop at that point. Our practice question, primary maths, book 7 of course. I want you to do questions, exercise 81. Exercise 81. It has questions up to number 3. 1 to 3. Then exercise 82. There are questions here where you're going to use the formula now. Number 1 up to 5. Number 1 up to 5. So Lana, calculate these questions well using the formula I've given you. And I'm very sure you are going to enjoy these sums as you do them because you are going to get them right. Whenever you are given a word question, it's wording question, read the word question and draw the diagram. It's very, very important to draw the diagram. Where the cylinder is open, show that it's an open one using an arrow. If it's an open one like this, you put an arrow there to mean it's open, and so draw here having one circular part. You are going to get it very right. So Lana, until next time, let us meet next time and discuss about something different. That is going to be, of course, a new chapter about measurements. That is, of course, volume. So enjoy, do the questions right, keep safe, sanitize and stay at home. Thank you and God bless you.